All right, section 1.2. I'm going to talk about some more definitions and kind of move through this. So 1.2 is types of data. So there are two definitions we're going to talk about. First is what is a parameter and what is a statistic. Well, a parameter is a numerical measurement describing characteristic of the population, and a statistic is a numerical measurement describing some characteristic of a sample. Now, what we usually do in statistics, because taking a population, taking the entire population is very difficult, and many times because the population can be very large, what we do is we take a sample, and from that sample we can make some measurements. So the measurements from the sample is called the statistic, and what we're going to do is we're going to take those measurements from the sample, assuming that our sample is representative of the population, and we're going to use those measurements to estimate measurements from the population. Now, it is, like I said, it is possible that you can find parameters. Like if I want to find the average age of the 23 students in my class, I could sample all 23 students, so I could actually take a population. But if I want to take the average age of everybody in my college, I might not want to do 4,000 students. I might want to take a sample that's representative of the data, and then I would get a good average for age. Types of data. There's two main types of data that we're going to talk about. It's quantitative and categorical. Quantitative is talking about numerical representations of data. These things, now when I say numerical, they actually represent counts. Now, things you have to be careful of is, like, if you look at the number on the back of a sports jersey, and you can say, hey, what numbers are on this team? Even though those numbers tend to be numerals, it doesn't mean that they're numerical, because they don't technically represent counts. Just because I might wear number 14 in my hockey team doesn't mean that 14 is representative of any count. It's just possibly my favorite number. Categorical data, or quantitative data, consist of labels, not numbers representing counts or measurement. So other categorical data might be your letter grade in the class, like A, B, C, D. Maybe your how many years have you been in college? So like freshman, sophomore, junior, senior. Now the reason why I say how many years, I have to be a little careful, because how many years would be numerical data, because it'd be 1, 2, 3, 4, 5, who knows how long. But to be a freshman, sophomore, or junior, or senior, it kind of depends on how many credit hours and so on. So when I give you those labels tend to be categorical. Or if I say like what's people's eye color, that's also categorical data. We also have discrete data and continuous data. Now, when we're talking about discrete and continuous data, now we're talking about numerical data, or that quantitative data. Now, discrete data represents like a finite or countable amount. So, like how many bedrooms are in a house should be considered discrete data, because you either have 1 or 2 or 3. How many cylinders in a car engine? How many community colleges in Michigan? So what we're doing is we're talking about counts. There's kind of space in between it. So the best way I can kind of describe this continuous data might look like this. It would be say I have like 1. Like here's our number line. So you have 1, you have 2, you have 3, you have 4, and so on. And there happens to be separation. So your discrete would have some separation between these data points, and it would be and that's what we consider discrete. Now, continuous data would not have this, you wouldn't have these breaks in here. It'd actually be more smooth. So if I talk about my age, we won't talk exactly about my age, because I'm starting to get sensitive about it, because I'm getting old, but whatever. So my age, I constantly get older every instant. So even though you might say that, you're 35 or 36 or 37 and so on, really as time goes on, now of course I started at 0. So, really your age is continuous data, because as you age, you're kind of moving from 35 to 36, 36 to 37, 37 to 38. And you notice there's no breaks in this. So, like age would be a really good representation of continuous data, because you're constantly getting older. Like your height would also be continuous data. Like, I might be 6'2", I'm not, unfortunately, but say I might be 6'2", but as I grow to that, I wish 6'2", I have to hit every height on the way. So if, as I'm growing up, even though I might be 6'2", again, I'm not. But as I grow, I'm hitting every single height until I get there. So there's no gaps in the data. You're not going to go 1 foot and then next day jump to 2 foot, the next day jump to 3 foot. You're not going to have these jumps like discrete data does. Now now we're going to talk about, we're going to kind of go a little bit further with this, breaking these two pieces down. So what we had is quantitative data and categorical data. What I'm going to do is I'm going to split each one of these things in two and talk about our levels of measurement. So our levels of measurement. What we have is, we're going to start out with the categorical. Categorical data tends to be not quite as strong because it doesn't represent counts. When it represents counts, you can do arithmetic on it. You can take subtractions, and those subtractions happen to be meaningful. So you can do math on it. Not to say categorical data isn't as useful. It just happens to it's harder to do. It's harder to manipulate. So our categorical data is going to be broken into two things. So the way to kind of remember this measurement is the French word for black, so nor. So we're going to have nominal. So the first we're going to have nominal. Now nominal data, there's no order. So this is categorical and there's no order. What I mean by that is examples might be like eye color. Now what I mean by no order is, I might have blue eyes or green eyes or brown eyes. And just because I have green eyes doesn't mean that I'm any more important than somebody that has brown eyes. Like there's no ordering scheme that would even be meaningful in there. So that's a type of idea of nominal. Now the other thing we can have from categorical is we can have ordinal. And ordinal does have order. So this does have order. So things like you can have your freshman, your sophomore, your junior, and then your senior. So those have order because freshman is less than sophomore, which is less than junior, which is less than senior, because you're actually moving through that ordered scheme. So it's still categorical, but this categorical has orders that ordered in this way makes sense. Now the other one we're going to have is our numerical data, and which also they call quantitative. I like numerical because it represents numbers, but then we're going to break this apart. Now this, since it's numerical, we get to do a little more statistics on it. The math becomes more useful, but we're also going to increase in levels. So the first one is going to be I, which is going to be called interval. Now interval means it has no natural zero. They also say that when you get into these levels, since they represent counts and these counts are meaningful, what they mean is that differences between these numbers make sense. So an idea might be temperature in Fahrenheit, in degrees Fahrenheit, or even temperature in degrees Celsius. The reason why these subtractions make sense is, it might be, 32 degrees today, and it might be 38 degrees tomorrow. So we know that today was 6 degrees less, or tomorrow is going to be 6 degrees more, and those things are relevant and actually useful to us. So the differences between these data actually matter. But there's no natural zero, because if I say 0 degrees Fahrenheit, does that actually mean the absence of temperature? It doesn't, because 0 degrees Fahrenheit really just it's not even really relevant, because 32 degrees Fahrenheit is freezing. So if you get to Celsius, even if you say 0 degrees Celsius, it still doesn't represent a natural zero, because it's not the beginning of temperature. So there are numbers that are actually below it, and it doesn't mean that zero actually represents nothing. Now the next one we have is ratio. Now ratio means that there is a natural zero, and that natural zero actually represents the absence of measurement. So again, remember, 0 degrees Fahrenheit doesn't mean the absence of temperature. It just represents a number on our particular scale. But ratio does have a natural zero. So I might say, like my height, for instance. If you're 0 height, that means you have the absence of height, which means you're not there. Or you can say like cylinders in a car. Actually, what I've done is my height is continuous and cylinders in a car is discrete, but they both have a natural zero. Because if I say 0 cylinders, then I'm really talking about no engine. So it's the absence of cylinders. So ratio does have a natural zero. So I'm gonna say height would be a good one right here. Now, that's why we say levels of measurement, because as you move this through the scheme, each one of these different levels of data are stronger and stronger and stronger. And that's 1 point.